Thank you very much, Daniel, for the introduction. BI for the invitation, this wonderful meeting. I'm Pablo Pineiro. Again, this is not a US Midwest accent. This is from Argentina. This is where I'm from. And I've been working in the ISU diagnostic lab for almost 10 years now. My job is diagnostic pathology, so I get to deal with all the samples that they send to the lab and try to help them to understand the situation with PCV2 diagnosis. So let's try to discuss a little bit this problem. So we heard Clayton, he presented the case, and this farm has oral fluid PCR positive. So what we do with that? So do they really have a PCV2 problem? So perhaps that's the main question here. It's just a simple PCR is going to help us to make the PCVAD or PNWS diagnosis. So just a brief reminder on what is the challenges that we have with PCV2 today. So that is a brief reminder of the structure of the virus, so that we probably want to remember that because it's going to help us to understand some of the PCR result diagnosis. So circular, small, double-stranded virus, which make it really resistant and perhaps is part of the endemicity that Clayton described in the farms. Brief history, we all know that this started bugging us over 20 years ago, and it's still a problem. Perhaps in the PCV2 industry, the vaccine is the most successful vaccine in veterinary medicine. So when we put that vaccine in the pigs, we could control the disease. But it's still a problem, and that's the important thing. And things have changed over time, and we see these waves with more and less problems, and variation on subtypes, and variation of protocols. So we need to understand what we're going to do with this. Still, perhaps after PRRS, one of the major economic impact in the swine industry globally. And just to remind you how long we have the vaccine in place, for me as a diagnostician, how long I have a problem to make a diagnosis. So over 10 years is when we struggle to start making a diagnosis of PCV2. Because before that was not that complicated. PCV2 was evident for everyone. We can look at pigs and say, this is PCV2. No, perhaps is the situation anymore. So reminder of the circovirus in general, PCV1 is still out there, not a pathogen, so not a problem with that. And the last few years, PCV3 has been described in the United States, and after the first description become globally associated with reproductive failure, multisystemic infection, and subclinical infection. And PCV4, who knows? I'll let you there. So the main question here is, does vaccination affect PCVAD diagnosis? So the situation, at least in the United States, is more than 90% of the farms are vaccinated. So how does it affect our diagnosis? And here are the three questions that I like you to, the three possible answers that I'd like you to think about it. No, doesn't affect the diagnosis. Positive PCR should be sufficient to make a PCVAD or PNWS diagnosis. Yes, vaccination, vaccinated animals can be PCR positive and have positive AIC. And no, the vaccination completely eliminates viremia and viral detection lesions. So I want you please to scan the code, put the answers in there, and we're going to walk through the presentation. I'm going to just let you find out if your answer is correct through the presentation. I'm not going to give you any answer there. Just a few seconds. I see most of the phone downs. Let's go. So, no, positive PCR should be sufficient to make a PCVAD diagnosis. Yes, vaccinated animals. No, vaccinated completed. We need to wait for more answers. 60. 64 was in the last one. So we're waiting for 3 more. Very good? Some people don't make their mind. 3, 1 more, 5. Oh, there's more people. Yes, vaccinated animals can be PCR positive and have positive AIC. No, positive PCR should be sufficient for the diagnosis. No, vaccinated completely eliminate viremia and viral detection. So remember those answers. I'm not going to tell you the answer now. We're going to go through the presentation. So why we do the PCV2 testing? This is the main question. So we want to break this in two parts, perhaps. Make the clinical diagnosis, so really make the causation of those PNWS cases, or PCV2 detection, which are two different things. Perhaps the two together make the PCV2 diagnosis, but keep that in mind that we are separating this in clinical disease and PCV2 detection. So what do we need to make the PCV2 diagnosis? So first, the presence of those clinical signs. Those animals that don't make too marked weight, they are low growth, they are wasted, pale, anemia, enlarged lymph nodes, all those descriptions, as Clayton described, this virus can mimic pretty much everything. So we need to see that clinical presentation. That's the first step to make the diagnosis. The second one is to have the lesions. It has some, thanks God, it has some lesions that is going to help us to narrow down the diagnosis. And those are basically the lymphoid depletion, the presence of multinucleation cells, the granulomatous inflammation, the interstitial pneumonia, the interstitial nephritis. With that, we can get closer to the diagnosis. And finally, the detection of the pathogen within the lesions. By different means, we can use immunohistochemistry, in situ periodization, we'll talk about those later. But those are the three steps that we need to make the diagnosis. With that, we can probably make the call. So some pictures, images of what PCV2 looked like perhaps in the past without the vaccine. This is the most common picture. We see these irregular animals in the same pain, animals that were not making to the market weight. So really backbones, really evident. So that was one of the first presentations. Then we started doing necropsies, and we found this enlarged lymph node everywhere. So tracheobronchial, hepatic, iliac, here mesenteric, inguinal, all of them were really enlarged. When we put those under the microscope, what we saw was this, the granulomatous inflammation. That's something characteristic, the presence of botryoid inclusion bodies. So, and here is not a pathology class. Basically, what I want you to remember is when you send those samples to the lab and you get that report back, what am I looking at? What do I need to do for my interpretation? So that report has to say somewhere granulomatous lymphadenitis. If I had that, I have my first clue that PCV2 is there. If I send a piece of lung, so when I open up those peaks in the field, I have those heavy, wet, non-collapsing lung with interstitial interlobular edema. And again, I send it to the lab, and they're going to read the histology, and what I wanted to see in my report is histiocytic interstitial pneumonia. That's basically what I'm looking for. And this is what I see here, these multinucleated histiocytes filling the alveoli of the pneumocytes. Interstitial nephritis, that's the other lesion, so we're going to see these white-spotted kidneys, and we will send a piece of this to the histology lab, the pathology lab, and they're going to describe the interstitial nephritis. So this is a normal section of kidney with a tubula, and here it's all replaced by lymphocytes and plasma cells. So again, when we receive our report, we were looking for at least the keyword that is going to give me a hint that PCV2 is going on is the interstitial nephritis. Why do we do PCV2 testing? So now things has changed. We don't look just for the presence of the disease. We are doing pathogen surveillance, pathogen detection. And the surveillance has different meanings. So what we're looking when we're surveilling, looking constantly for the virus. We're looking for virus introduction, genetic changes, viral dynamic within the farm, within the herd, within the systems. Establish if we have a stable or not stable farm. So presence of the virus in association with seropositive animals or seropositive viremian cells. So those are perhaps the two different stages that we're looking at. We can also use surveillance to evaluate vaccination. So we want to see if our vaccine, I wouldn't say is effective, but at least is in place. So we want to see vaccine compliance, vaccine programs, vaccine types. And I put this one there because in the United States, as Clayton mentioned, everyone has a magic bullet. And here the magic bullet is, I have a PCV2 problem, I'm going to switch my vaccine, and I switch the brands, and I still doing testing to evaluate if the brand work. So it's there, and it's one of the reasons why people do this. So all these are the reasons, perhaps, to do pathogen detection, the two big buckets, surveillance and vaccine evaluation. What are the tools that we have to do this pathogen detection? So PCR, basic PCR is the main one. It's going to tell us yes or no. It's just the result that we can get. We can get more advanced with the quantitative PCR, where we can quantify the amount of virus. So CT versus genomic copy number, that I put that one in there just to keep in mind that is something that is give us an idea of the amount of virus, but cannot be really, CT values cannot be really transpolated amongst labs. So if we are using in our farm different labs, the CT values can be different among labs, so standardize that amount of virus when we're doing our farm interpretation could be hard. So this one perhaps is more accurate. Looking into genomic copy number would be more accurate to cross-validate those results among different labs. When we're talking about PCV2 typing, it's something that people are commonly doing now just to evaluate what subtype is circulating in the farm. So we know there has been a dramatical shift in different subtypes globally, so it's something that is another piece of information that we're doing when they're doing pathogen detection. Full-length analysis, so there are some people doing that kind of analysis, and it helps us to understand the variation and dynamic of the virus within the farm. There are other tools for direct detection, the PCV2 AIC and the C2 resection. I showed some of the pictures. That one has helped us to identify pathogen within the lesion. And last but not least, virus isolation is still a really viable tool for direct detection. Indirect detection, so sometimes we forget, we can look into the presence of antibodies. And that one is, we need to be really careful how we do the interpretation. ELISA and IFA are still the most common tools. But we have other tools that is going to tell us a little more about the biology, what those antibodies mean, if they're useful or not. It's just presence, probably doesn't tell us much, but we want to understand the biology. So virus neutralization would be another test. Those are the tools. What samples are we going to use to make those evaluations? So tissue has been the most traditional one, but as Daniel mentioned, oral fluid processing, umbilical cords, tongue or tongue fluids, serums are all other samples that we can use to do this pathogen detection. So now that we have the tools, that we have the samples, we're going to put this in a clinical case and see if we can kind of do an interpretation or mix of all these results. So we did this experimental study where we tried to mimic what really happened in a farm. So we got 100 pigs that all of them were vaccinated with PRRS-MLV at day 0. This means 5 weeks of age. And we then vaccinate 80 of them with PCV2 vaccine, and we left 20 of them non-vaccinated with PCV2. What we did is a co-infection challenge. We infect them with PCV2D, and we infect them with 174 pairs. And after that, we collect, of course, clinical data, blood samples once a week, and at day 56, they were euthanized, and we collect samples to evaluate the performance of different tests. So here is just the clinical data. We look at mortality. So really simple. Up here, vaccinated animals, we barely lost 5% of them. So clinically, the vaccine, both of them work. That's not a question, not a problem. So when we look at non-vaccinated, by 30 days post-challenge, we lost almost 50% of them. So the protection was not there as clinical. So looking into viremia, and this is perhaps something really interesting. And one of the concepts that we need to think about it. So 3 weeks post-challenge, we still have a really high viremia, 10 to the 6 in vaccinated animals. So both of them made the peak 3 weeks post-infection. But perhaps the take-home and the most important thing here is the vaccine is not completely abrogating the viremia in these animals. And that's something that we probably need to use to do our further diagnostic interpretation. We're going to look into vaccinated animals which have a really high viral load. We look into the PCR. It's the samples that we normally receive in the diagnostic lab. They send us a piece of lung, lymph node, tonsil, kidney, and they want us to do a PCR. So look at this. The orange ones are the non-vaccinated animals, green ones vaccinated. So it's about 10 CT difference between the vaccinated and non-vaccinated, but still, the interesting part here is that the vaccinated animals still have in this range of 25 CT performance. So if we remember some of the concepts that Daniel described when people look into clinical animals, is below 28 is when we start getting problems. So this is a vaccinated animal that make it all the way through the challenge, so they never got sick. But if we look at this, they still have a really low CT. We look at the other diagnostic tool that we described before, the immunohistochemistry. We did AIC in lung, lymph node, and tonsil. And there are two things here. So one is that the vaccinated animals couldn't completely abrogate the pathogen replication on the tissue. They still be detected on IHC. So this is something that, if we think about vaccinated animals, they are positive by PCR and positive by IHC. So in a regular scenario, we will call this animal a positive PCV-AD. So what we try to do is mix these results and see what happened here. So we got all the vaccinated animals and look into the CT values down here and IHC score. And yeah, the vaccinated animal had a really low CT, lower than 20. The non-vaccinated, sorry, lower than 20 with high IHC score. When we look at the IHC in the vaccinated animals, in lung, we have the IHC is completely pretty much abrogated there, which is fine, but this is interesting. Look at this. We still have animals with really low, below 25 CT, and they are vaccinated that were not clinically evident. We look at different tissues. Now we're going to do this same thing in lymph node. Again, no vaccinated, kind of not a problem, really low CT values, high IHC score, so we can make the call really clear. What happened with these vaccinated animals? Look at this. So almost 50% of them, they're still IHC positive, low score, but it's still positive, means that the virus is still replicating there, and we still have this really high number of peaks below 25. So that one, it could really bring a problem in our interpretation of results, because these animals never got sick. The same thing looking into tonsil. So non-vaccinated, low CT, high IHC, vaccinated animals, we still have a really high proportion of positive animals and really low CT value. So some of the conclusions, and I hope this answers one of the questions that you have there. So the vaccine reduced the viral load in serum and tissues. The amount of PCV DNA and antigen detection by PCR strongly correlate with vaccination status. So we can see that non-vaccinated has a really low and high IHC, and the vaccinated still have some IHC and more variable PCR results. The important thing is to perhaps, when we do the interpretation, have in mind the vaccination status of the farm. We need to know where that farm was in the vaccination program. So we already saw the poll results, so I saw that most of you are confident that the vaccine can interfere with our PCV2 or PCV-AD diagnosis. For those that is still thinking that the PCR should be sufficient to make the diagnosis, I hope that this create some more questions and debate for you. So there is another little piece of information that I like to put in there when we do our diagnosis. So we talk about the direct method. Now we need to perhaps mention the indirect detection method. So when we look at the vaccine performance, perhaps the most important thing for us is the clinical performance. We're going to know how much money do we make out of that vaccine that we put in the pig. But that is sustained by something else, which is the clinical presentation. How we evaluate the performance is we want to see that those pigs don't get sick, don't get those clinical signs of PCV-AD, that we don't have reproductive failure, or we don't have the subclinical disease. That will be the clinical presentation. But all of that is supported by this, and it's something that we don't look into really very often, which is the immunological response that we obtain from that vaccine. And the immunological response can be evaluated by just the humoral response, basic IgG, IgM response, the neutralizing activity response, and the cellular activity. So what I wanted to show you is something that we've been doing about this level. So humoral response, the basic humoral response that we normally do in our farms is perhaps ELISA and IFA, and that is going to tell us total IgG and IgM antibodies, but doesn't tell us if those are protective or not. And this is the next step. To see neutralizing activity will tell us a little more about protection. So what we did in here is we have this 4 group of animals, no vaccinated, animals that were vaccinated with A in green, with D on blue, and a mixed vaccine. We put 1 shot of D and 1 shot of A. So then we got the serum of those animals, and we evaluate the neutralizing activity. So the neutralizing activity is to see how much virus has been neutralized, in this case, against PCV2D. So look at this. When we look at animals that were vaccinated against D, the neutralizing activity against D virus reach about 100%. But when the same serum tried to neutralize PCV2A, it barely get 20%. So from the biological standpoint, it gives us some protection, but it's not full protection when we have this heterologous challenge. That's the concept. And it's something that we can control in the pharma. We don't know what subtype is going to be there. So we need to be really strategic on what type of farm, or what type of vaccine are we going to use. In this other situation, we look into animals, we look at the same zeros, and when we try to see the neutralizing activity against A, animals that were vaccinated with A, they reach 100% of neutralizing activity. But when we put the same serum on animals that were vaccinated against D, we get 60% of neutralizing activity. Again, the heterologous protection is not 100%. That's the important take home here. So we can be using one subtype of vaccine and perhaps get a different response depending on the subtype that is circulating in the farm. That's perhaps one of the biological backgrounds that we see the difference in vaccine response. That could be one of the questions. And perhaps this kind of test will help us to do that interpretation. So some of the take home, PCV2 detection does not represent PCV-ID diagnosis. PCR detection can determine the viral presence of PCV-ID, but we need to understand that we perhaps going to need a combination of tests to make the PCV-ID diagnosis. A combination of molecular testing, histological evaluation, and presence of the pathogens within the lesions. So vaccine can reduce the viral load in serum, but we don't need to expect, we can expect a negative farm. That's a given there. So learning about the background on our farm in vaccine, it will help us to better evaluate the laboratory results. We may need to consider, when we try to do indirect testing, different approaches, such as virus neutralization instead of just ELISA and IFA. So with that, I'd like to thank some of my student colleagues at Iowa State and our colleagues in Birmingham and Pipestone that helped us to do this testing. Something that I like to perhaps keep the conversation is we mentioned direct detection assays and how to apply them. But Daniel and I list some of the matrices that can be used for indirect detection, so such as those oral fluids, tip-tongue fluid, processing fluid. So perhaps Daniel can help us to understand how we're going to apply those matrices in diagnostic future. With that, thank you very much.